In this tutorial, we will learn how to use RapidMiner to optimize a prediction model that employs multiple regression. And our guiding principle here will be that a prediction model should be parsimonious while doing a good job of predicting. I'm assuming that you're familiar with the conceptual foundations of multiple regression and that you have watched my prior 2 tutorials that show how to use RapidMiner to build multiple regression models. So let's first take a look at the data set that we will be using for this exercise. So we have data on about 1700 houses, and for each house we know its price and a collection of other attributes. Some of those attributes, such as lot size, the age of the house, the living area, are quantitative, while others, such as type of heating, the type of fuel, the type of sewer connection, those are nominal or qualitative. Now, if we were to use all 16 independent variables that are there in this data set, then the prediction equation that we would be estimating is what you see over there. We would be predicting price as a function of those 16 independent variables, and we would be estimating 17 coefficients, so 16 coefficients for the variables plus the intercept. But when we are talking about optimizing the prediction model, the question we are asking is, do we really need all 16 independent variables to do a good job of predicting the house price, or can we optimize the model and do with fewer variables? So as a reference, I have built a prediction model using multiple regression and all those 16 independent variables. So very quickly, in this first top box, you can see the process, the RapidMiner process surrounding the operator linear regression. So on the left hand side, I have prepared the data to train and validate the linear regression model, and the performance metrics are being generated on the right hand side. But the important aspect of this first run is when it comes to the linear regression operator, in the parameter panel, you can see that I have set the feature selection to none. In other words, I've told RapidMiner, keep all the independent variables, don't reduce anything, don't shrink anything. So the result of that prediction model is that we use all the independent variables, so a large number of independent variables, and the error performance, the root mean square is 55,411, R squared is 0.7. And by comparison, I ran this prediction model again. Here, this is what you see in the second box below. But now notice for the linear regression operator, for the feature selection, I've set it to t-test. So I've told RapidMiner, select a subset of the independent variables based on the significance level of 0.01. And RapidMiner goes through that process and tells me, well, I've selected 11 independent variables, not all of them. So it's a little more parsimonious model. There are fewer independent variables, but the error performance has worsened just a little bit. So the root mean square error has increased from 55,411 to 59,151. And the R squared has worsened a little bit from 0.7 to 0.67. So the performance has worsened just a little bit, but we have a more parsimonious model. That's essentially the reason that we are trying to go through is, can we build more parsimonious models but not lose too much by way of error performance in terms of prediction ability. Now, you can try these different feature selections manually to optimize your model, but the technique that I want to show you here in this tutorial is a technique called forward selection that RapidMiner has that automatically goes through the selection process and generates a parsimonious prediction model for you where the model is reasonably compact and you don't lose too much by way of performance, and the error performance is also quite good. Okay, so with that setting, let me start up RapidMiner. Okay, now the first few steps here are absolutely identical to building a multiple regression model. So let me go through those somewhat quickly. I bring in the data set and using the retrieve operator, and then using set role, I tell RapidMiner that I want to identify price as my dependent variable by specifying it to be a label. So I pick price and then set that it's a label. And now I want to convert all the qualitative variables, the nominal variables that I have, to numeric, because the regression algorithm requires all variables to be numeric. So nominal to numerical operator here, I bring it in, I chain it with the previous operator, highlight nominal to numerical, move over to the parameter panel, and then tell RapidMiner, please convert all my nominal variables to numerical. So I pick the subset that is nominal, and from the attribute list, I click on select attributes, and RapidMiner knows that these are all the nominal or qualitative variables. I click on central air, shift click on waterfront, that highlights everything, all those variables, and I move them over as a list. Okay, so I have now converted all my nominal variables to numerical. Now I have to remove one dummy variable. This is dummy variable coding. So the nominal variables were converted to numerical using dummy variable coding. So I have to remove one dummy variable for each nominal variable due to multicollinearity. And that's what I'm going to do next using select attribute rather. The select attribute operator. So I pull that up, chain it with the previous one, click on select attributes, and now I click on subset, and I'm about to tell RapidMiner which attributes I want to pick. So essentially I'll choose the attributes that I want to drop, and then I will invert the selection. So this first attribute A is just a row number, so I have to get rid of it. And among essentially what I need to do now is to remove one dummy variable for each qualitative variable. So for central air, I will remove central air equals yes. For fuel, I will remove oil. For heating, I will remove hot water steam. For new construction, I will remove yes. If I scroll down, for sewer, I will remove none. And for waterfront, I will remove yes. Now, the reasoning behind choosing each one of those dummy variables is that in the data set, they occur least frequently. So out of fewer houses have central air than don't. The fewest number of houses use oil as their fuel. So there's a basis for selecting this, and you have seen this in my previous tutorial on data preparation. So I have selected the variables I want to drop, so I invert the selection. So at this point, what I've done is I've retrieved my data, I've told RapidMiner what my dependent variable is, I've converted nominal to numerical, and I have dropped one dummy variable for each nominal variable. So far, absolutely identical to what we did for building a multiple regression prediction model. Now comes the forward selection part. So let me just make a little space for myself so that visually things don't get too cluttered. Okay, so the operator that I want to bring up is called forward selection. So here I bring it up, and you notice right away that it looks a little bit different from the other operators in that there seems to be an operator hiding behind the forward selection, and that's for a reason. This forward selection is what's called a nested operator in RapidMiner. So just informally, the way forward selection works, you can read further details here in the help section, in the context sensitive help. So if you scroll down, you get a lot of detail about how the forward selection works. So basically it adds one independent variable at a time until there is no further improvement in performance. That's basically how forward selection works. Okay, but it is a nested operator. That means it will do, so there has to be sort of a subroutine, an internal operator that feeds into forward selection, and that will be the linear regression. We will see how that works. But first of all, let me feed the raw data into forward selection. Okay, so in the forward selection, what it does is it will try to pick independent variables based on their performance. So when I double click on the forward selection operator, excuse me, I drop down one level, and this is where I build the actual linear regression model that will be used repeatedly in my selection process. So the raw data is available to this subroutine from this examples port that you see. So the first step is I want to split my data set into a training and validation data set. So split data. So I bring the split data operator here. I connect it to example. So notice that this data that's coming into split data is coming from the higher level. The forward selection operator will feed this data in here. So for split data, again, I will go through it a little bit quickly because I've done this before. Edit enumeration, I add an entry. So the 70%, the first 70%, not first, 70% of the data will go for training. I add another entry where I'm telling RapidMiners that 30% of the records will be used for validation. So now I bring up the linear regression operator, put it in here, and I feed the training partition to linear regression. So I've given it the raw data for training. And now obviously I need to evaluate how good this training was. So I use apply model. You have seen this before for the building multiple regression models, prediction model. So here I apply the model. The apply model operator needs the trained model. So I connect the output of model from the trained training. And here is the validation data set. So the trained model validation data set, and this generates the predicted values. So now I can actually do performance calculation. So here's performance regression. This is the operator that I use to actually measure the performance. So I feed the actual and predicted values to the performance operator. And this performance is fed back to this output port. So this input port came from the higher level forward selection operator. This output port feeds back to the port. There's a performance port in the forward selection, you will see in just a moment. So for performance, this performance operator itself, the root mean square is the general metric, the most common metric that's used. So you can see I'm telling RapidMiner that this first criterion is the one that it should use as its performance metric. But since we are doing regression, I also want to know what the squared correlation is. That's the R squared value. So I just picked this value as an extra bonus for me to get. So this is the subroutine. And all that this subroutine is doing is evaluating a linear regression, its performance, and performance being measured using root mean squared error. Okay. So now if I click on this up arrow, I go back to the higher level process. So notice what has happened. So the forward selection operator, that you see that exclamation mark has gone. So now the forward selection operator is satisfied because its nested inner operator has been defined. Okay. So the examples, the data set that was fed to forward selection is fed to the subroutine. The subroutine does its calculations and feeds the performance back over here. Okay. So now if I want to actually see the output of the forward selection process, I need to put in another linear regression operator here. Here's linear regression. Okay, so what happens is that the trimmed model, so the forward selection process goes through adding one independent variable at a time and feeds that to the lower level nested procedure, and the nested procedure evaluates the error performance and feeds it back, feeds that performance metric back here to the forward selection master process. and the master process keeps adding independent variables until there's no further improvement in performance. Once that process stops, the trimmed model is fed. I can feed to the linear regression operator over here, okay, and I can get the model. I want to see the model output itself. I want to see what the model looks like. Here's the result, and I also want to see the performance, how it performed in terms of root mean square error and the correlation, the R squared value. Okay, so let me go over this architecture again of this forward selection process. So on the left hand side, I've just prepared the data, basically converted qualitative to numeric, identified the dependent variable, and then dropped one dummy variable to get rid of the multicollinearity problem. The main star again of this tutorial is this forward selection operator, and you can see it's a nested operator, which means it needs another operator behind it that repeatedly runs and runs like a subroutine. It calls that procedure over and over again as a subroutine. So informally, again, you can see the details in the help section over here. The way forward selection works is it picks one, it keeps adding one independent variable at a time to the model until there is no further improvement in performance. And at each stage, it adds the independent variable that gives the best improvement in performance. Okay, so that's why it has to repeatedly call the linear regression operator as the subroutine, which returns the error metric in order to enable the forward selection operator to keep doing its job. All right, so everything is set up now. I'm going to run this this process, and let's see what we get as the output. Okay, so let me bring up the linear regression model. Do you see how dramatically it has compressed, or rather simplified, optimized the model? So this forward selection procedure, it has come up with a model which instead of 16 independent variables has 1, 2, 3, 4, just 4 independent variables. So highly parsimonious. So that's certainly desirable. But I think a natural question to ask is, have we given up a lot by way of performance? Okay, so let me click on the performance vector over here. So you can see that the root mean square error actually has gone down a little bit. It's improved. It's 55,068. I don't know if you remember from when we saw those two baseline cases before we started the RapidMiner model building. The root mean square error was around 57 or 58,000. So we have improved in terms of the root mean square error metric. Not only have we gotten a slimmed down model with only 4 independent variables, but the root mean square error has also gone down. Now, how about by way of R squared? So you can see the R squared, if I remember correctly, was 0.67 with the variable that had some 12 independent variables. Here, we have trimmed it down to 4 independent variables and haven't lost a whole lot by way of R squared. We still are at 0.63, so it's pretty good. Okay, so here you can see the end result has been a model. This is the equation. So when I click on description, you can see this is the regression equation itself. But let me get back to the data itself. So the forward selection process has resulted in a highly trimmed model, an optimized model, which uses just a few of the independent variables, and yet gives us pretty good error performance. So this is the thought process behind optimizing a multiple regression model that has been built for prediction purposes. And you can try out different manual methods also, as I showed in the beginning of this tutorial. There is another technique called backward elimination, which is sort of the reverse of forward selection. There you start with all the independent variables and gradually keep dropping one variable after another until you get a very slimmed down model and there's no further worsening of performance. So that's another technique that one can use. But essentially, this is a way of an automated technique that RapidMiner offers to us to optimize a multiple regression model for prediction purposes. So thank you for your attention and thank you for watching.